All right, so this is going to be our third video for Unit 3, Day 3 in Algebra 2. In it, we're going to talk about even and odd functions. So let's jump right in. So what is the difference? So we've got some definitions here. If you want to pause the screen and go ahead and write them down, you can. But I'm not going to toil too much over it. Um, I do strongly recommend you go over these two examples here. Okay, but real fast, I just want to talk about the geometry. So if a function is symmetrical about the y-axis, then that means it is even. Okay, so for example, this function here, f of x equals x squared, is definitely symmetrical about the y-axis, right? We see clear symmetry from here to here, right? So this is indicative of the fact that it is absolutely an even function. Okay, and we'll talk about the algebra here on this next slide. Okay, now let's talk about if a function is odd. Well, then it's symmetrical about the origin. Okay, so this function here, f of x equals x to the third power, x cubed, is in fact one such function, and it looks like this. Okay, and we'll get into cubic functions later. But basically, we see that we have rotational symmetry about the origin. Okay, this is indicative of a function being odd. Hence, f of x equals x to the third power is an odd function. Okay, so just to kind of prove some points here, uh, we're going to give algebraic and geometric proof that these functions are either even, odd, or neither. Right. So let's look at the algebra first. So number one is asking us to consider f of x, and we see here f of x is equal to 2x squared minus 3, right? And let me bring my Desmos graph over here, see if I can get it to fit in the screen. Okay, so if I go ahead and type this in, let me change my contrast because I hate the bright screen. Just drives me a little bit crazy. So we have 2x squared all minus 3, right? And we see very clearly that we have that we have symmetry about the y-axis. We have a vertical line of symmetry right here that cuts it perfectly in half. And we can also see evidence by the x-intercepts, right? They're both equidistant from the y-axis, right? So that would be our geometrical proof, right? But we're asked for algebraic proof, right? So that means if it's even, right, that f of x should be equal to f of negative x. Okay, and you're not going to always know off the top of your head. The only reason I know off the top of my head is just because I love this stuff. I've been looking at this kind of stuff forever, right? So you're not going to always know. You're going to ultimately just have to try, right? So f of x should be equal to f of negative x based on what we see here on the graph, just because we have symmetry about the y-axis. So if I replace every instance of x with negative x, I should arrive at the exact same function that I started with. So let's try that. So f of negative x is equal to 2 times negative x all squared minus 3. Negative x squared, well, that's just negative x times negative x. A negative times a negative is a positive. So that leaves us with 2 times positive x squared minus 3. And we see that f of negative x and f of positive x are the same. And therefore, this guy is even, right? So we have algebraic and geometric proof. Okay? So moving on to our next example. So number 2, we're looking at g of x. So 3 times the cube root of x, right? So let's see what the graph of this guy looks like. So 3 times the cube root times this cube root of x. Okay, so we see that we have rotational symmetry about the origin here. Okay, so this tells me right off the bat, just by looking at the graph, that it must be odd, right? But again, we still have the burden of algebraic proof placed upon us. So that means if it is odd, that f negative f of x should be precisely equal to f of negative x. Okay, so let's see if that is in fact the case. So that means f of negative x, right, would be 3 times the cube root of negative x. Okay, now this is kind of tricky, right? What we need to think of is, would it be true to say, for example, is the cube root of negative 8, which we know would be negative 2, right? The cube root of negative 8 would be negative 2 because negative 2 to the third power would be negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. So what this means here is that negative cube root of positive 8 would also be equal to negative 2. Yes? So we know that the cube root of positive 8, well, that would be 2. And then we've got this negative sitting outside here. So we know that that's going to give us the exact same answer. So that means cube root of negative 8 and negative cube root of positive 8 are precisely the same thing. Okay? And what that tells us is, that this is the same thing as saying this, which in fact is this. Okay, so negative f of x would just be f of x multiplied by negative 1, which gives us exactly this. So because this is true, and of course because our geometry also tells us that we're symmetrical about the origin, we know this function must be odd. Okay, now let's look at something a little bit different. So let's look at number 3. We're looking at h of x here, right? And I know that this function is going to be neither. Okay, now just to prove a point, let's throw this into Desmos and just look at the visual of it here. Let's look at the geometry. So 4 square root of x minus 2 all plus 1. Okay, so let's make it full screen here so we can get a better picture. Now, what do we see? Well, is there symmetry about the y-axis? Well, absolutely not. Is there rotational symmetry here about the origin? Absolutely not. Okay, so it's very clear this guy is not even, nor is it odd. Okay, now, again, let's prove so algebraically. So we're going to have to prove that f of x does not equal f of negative x, and that negative f of x does not equal f of negative x. Okay, so pretty simple to do. If I say 4 times the square root of, and let's go ahead and say that this is going to be f of negative x, 4 times the square root of negative x minus 2, and then plus 1, right? And then I go ahead and calculate this guy, negative f of x. Well, that would just be negative 4 times the square root of x minus 2, all plus 1, right? And we see very clearly this guy here and this guy here are not equal at all. Okay, and if you're ever not sure, you can use your calculator and just try some arbitrary calculations, right? So if I go to, or even faster, I can just go and graph these. So negative 4, and it'd be faster if I use my stylus. Control x squared, x minus 2. Where's the minus? And then all of that plus 1. Okay, so that one looks that way, right? And f of negative x. So let's go ahead and graph that one at the same time. So that function is positive 4 times the square root of negative x minus 2, all of that, plus 1. And we see they're in no way, shape, or form equal. Otherwise, they would overlap each other completely. They would be the exact same function, right? So these two are not equal, right? And we obviously know this is also true, right? Because it is not the same thing to say that the square root of negative x minus 2 is the same thing as the square root of positive x minus 2. Okay, so that tells me, based on the graph that we saw and the algebra that we just did, this is neither even nor odd. Okay, so that's going to do it for this video. Like always, shoot me an email. Let me know if you have any questions. You know where to find me. Goodbye.